Welcome back to Math 171 Pre-Calculus Algebra. In this video, we're going to talk about the fundamental theorem of algebra. So what the fundamental theorem of algebra states is, so we have the actual statement and then what we're actually going to use it for. If f of x is a polynomial of degree n, where n is greater than or equal to 1, then f of x equals 0 has at least one complex root. And I do want to be careful because sometimes complex gets misinterpreted. 3 plus 0i is a perfectly valid complex number. Thus, 3 is a complex number. So it's not saying that we have to have something with an I in it for this. We just have to have a root that's complex. Or a root within the complex numbers. Real numbers are perfectly fine. But this does give us something nice. So we know that f of x has a 0. So we'll just do x minus c. And then it's multiplied by something, q1 of x. Now, if f of x were of degree 1, that would just be a 1, but... well, then we get the idea of mathematical induction going on. Now, if that's not a constant, that's another polynomial of degree at least 1. So it has at least one complex root. We can find it and keep on going from there. So what we're going to use it for is to say a polynomial of degree n has exactly n zeros where zeros are counted by multiplicity. So, we know that if, say, a polynomial is degree 5, there has to be 5 zeros. Now, some of them could be repeated zeros, like we had in the problem in the last video, where 2 is there twice. But we know that we have to have exactly n complex zeros. So that concludes this video. In the last video, we're going to take a look at one more way that we can narrow down the possibilities for the zeros of a polynomial.